Just ionic solids, ions are the constituent particles here. Good example which we can think of is this NaCl, Na plus NCl minus ions. Correct? So here if you see, this is my Na plus, Cl minus. Green is all my Cl minus. And this, they are strong, these are solids composed of positively charged ions and negatively charged ions. Na plus, Cl minus. Since they are charged ions, they are held by a strong Coulombic force, electrostatic force of attraction, right? That force of attraction is all the more strong because not partial charge, no, we have the real charge. Correct? Since the attraction between them is strong, because the real charge, they are hard and brittle. Correct? Why? Because the force of attraction between them is very, very strong. Since the force of attraction between them is very strong, they also have high melting point and boiling point. But they are insulators. Because why? Because they don't have any free electrons to move, to pass, to conduct electricity. But in the molten state, or in the dissolved state, when you melt it or by heating it or when you dissolve in water or something, then what you get, they are free ions. For example, this is my Cl minus ions. You get free ions. So these free ions can conduct electricity. So sodium chloride as such is in the solid state is non-conductor of electricity. But in water, if you put sodium chloride, common salt, it will conduct electricity. Another example can be NH4, NO3, NH4 plus, NO3 plus. Correct? So these ionic solids, very strong force of attraction because they are the real charge here. Since the force of attraction is very strong, logically it makes sense this will be hard and brittle. Also it will have high melting and boiling point. But since there was no free electrons, they are insulators in solid form. But the moment you dissolve in water or when you put in the molten state, it will conduct electricity because it will have free ions. The next is the metallic solids, pretty interesting. So in metallic solids, if you see the metal, they are nothing but they are ordered collection of positive ions. There are so many positive ions, they are all metallic ions actually, right? And they are surrounded by free sea of electrons. They are all electrons. The blue ones, you see, they are electrons, free electrons. Since there are so many free electrons, these free electrons, I will explain you, they are responsible for electrical conductivity and they are also responsible for thermal conductivity. In fact, they are responsible for its malleability, ductility, shine, everything. So let's see how it works. See, for the electrical conductivity, if you apply electric field here, from let's suppose you put a positive charge, negative charge here and a positive charge here, some battery you connect like that. Now what happens is the electrons will flow from here, the electric field created. So electrons will flow through this network of positive ions. And there is free electrons also to take part. When the heat is applied on one side, thermal energy is uniformly spread by these free electrons. These free electrons help in spreading the thermal energy. So these electrons are responsible for both electrical and thermal conductivity. Right? Let's talk about, so let me write the thing we discussed is thermal and electrical conductivity. Let's talk about the shine, the luster, color, the shine. So this is also because of free electron. How? See, when the light falls on the electrons, since they are free electrons, this atoms in the electrons, the shells, they jump to the higher orbital, and when they come back, it glows, it radiates back the light, the Bohr's things which we have discussed. If you want to know more details, you can watch the atom chapter where we discussed about this. We have this atoms, light falls on this, right? This in this we have this. Here we have electrons, right? These electrons will jump, correct, to higher orbitals, and then it will come back to a lower orbital and it will emit light. Same thing, these electrons are there, it will jump back, go to higher orbitals. When it absorbs light, it comes back to its normal orbital and it emits light, and that's why it has luster and colors, correct. Now let's talk about the malleability and ductility. Malleable and ductile. It is malleable and ductile, right? Malleable, you can melt it. Ductile, you can make a small thin of wire also of this. Why? These free electrons allow metals to slide over each other, and that's why they are malleable and ductile. For example, copper, aluminum, all these metals have free electrons, correct. So there's a force between positive and negative, and these force hold this metal ion together. Now, since again we are talking about the real charge here, positive and negative, the force of attraction is more. Since the force of attraction is more, this metallic bond, the attraction is more, they are rigid. It's a rigid structure. Since the structure is rigid, they have high MP and BP. That is high melting and boiling point. Correct. These are the properties of the metallic solids. They are thermally and electrically conductor. They have lusters and colors, malleable, ductiles. They have rigid structures. They have high melting and boiling. All these things are happening because of the electrons. Correct. So hope you understood what is metallic structure, metallic solids. For example, if you see this gold, iron, copper, they have lusters. They have high melting and boiling point. They are also conductor. Let's talk about the last crystalline solids, that is called covalent solid. Right? They are covalent solid. There is a mistake here. This ionic solid is not part of molecular solid. It is part of crystalline solid. Right? Similarly, this is also not part of metallic solid, is also not category of crystalline. So these are all directly part of crystalline solid. They are not part of molecular solid. Molecular solid will have three parts. We discussed that: polar, non-polar. That. So let's start with the covalent solids, also called network solids, because the strong network it forms. Looking at the shape, you can see the networks, right? The strong network. So here the constituent particles are atoms. Here we have atoms, carbon atoms. Here you see, in case of diamond, graphite also, we have all these blue dots are carbon atoms. So the constituent particle is atom. And they are connected by covalent bond. I hope you understand what is covalent bond and ionic bond. If you don't understand, please watch my previous videos where we explained this. So a network of covalent bond is formed throughout the crystal. Throughout the crystal we have a network of covalent bond, right? And this is a giant structure. It forms a giant structure. Correct. It forms, let me write here, giant structure. Since they form a giant structure, it's also called giant molecule. It has been given the name of giant molecule because it forms a giant structure. Correct. So these are generally crystalline solids of non-metals because it forms the covalent bond. So generally it is non-metal. And they are also very, very strong. If you see, they are all pretty much arranged, strong and directional, you can say. Example, diamond, silicon carbide, graphite. There's so many examples of this. They're very hard and brittle. Why? Because see, the force of attraction is more, and plus they have such a giant network, so they're very hard and brittle. They're insulators. Exception, graphite is the exception. They are generally hard, but again graphite is the exception. We have discussed the structure of graphite because these layers, right, they can slip over each other, so it forms layers. This layer is one, this is one strong layer, the one strong layer. They can slip over each other. That's why graphite is soft and it conducts electricity. But that is the exception. But in general case, they are very hard and brittle, and they are insulators. So we talk about the graphite structure. It has a typical structure. These carbon atoms are arranged in different layers, as I told, and each atom is bonded to 3 of its neighboring atoms. If you see this guy, 1, 2 and 3, correct? And the 4th one, if you see, is present between the layers, and they are free to move. They are free to move actually, and that's why they connect electricity, and they are soft also, because these layers slide over each other and they are soft. It's a very good lubricant, solid lubricant at high temperatures. I told the normal lubricants which we use in